In this video, we're going to look at non-linear transformations of roots. And this works in just the same way. It feels like it's going to be much more complicated, and it turns out it's not. So, same cubic as before. It has roots of alpha, beta, and gamma. Find the equation of a polynomial with integer coefficients with the roots 1 over alpha, 1 over beta, 1 over gamma. So once again, we just state the relationship, which is that our new roots w are 1 divided by our x roots. Well, if we just rearrange this, we get x equals 1 over w. And into this equation, we sub that. So we've got 1 over w cubed plus 3 times 1 over w squared minus 2 times 1 over w plus 5 equals 0. And look, I can just multiply everything through by w cubed. When I do that, I'm left with 1 here. I'm left with 3w here. I'm left with minus 2w squared here. And I'm left with 5w cubed equals 0. And there's my polynomial with integer coefficients, whose roots are 1 over alpha, 1 over beta, 1 over gamma. And we can check these just in the same way that we did before. I'm not going to go through that again. Check out the previous video on linear transformations to see that. We would just find some roots of this original one, write down one of them, and just check that 1 over that appears somewhere in the roots here. Okay, let's try an exam question here. So, and this is useful because it can show us, it's a practice of the method we've used, and it also highlights an alternative method, which I don't normally suggest, but is maybe appropriate sometimes. Let me show you. So here's a quadratic equation. It has roots alpha and beta. Write down the values of alpha plus beta and alpha beta. Okay, so this is our roots of polynomial stuff. So our a is 2 here, our b is -1, and our c is 4. So we know that alpha plus beta is minus b over a. So that's 1 over 2. We also know that alpha beta, the product of the roots, is c over a, which is 4 over 2, which is 2. So that's done. Show that 1 over alpha plus 1 over beta is a quarter. Okay, well, I'll do that one down here. So 1 over alpha plus 1 over beta is beta plus alpha over alpha beta. Okay, well, we know those two values. Beta plus alpha, alpha plus beta is a half, and alpha beta is 2. And that's a quarter, and that one's done. Okay, so find a quadratic equation with integer coefficients such that the roots of the equation are 4 over alpha and 4 over beta. So let me show you two approaches that we could take for this. So the first approach is to just simply use the technique that we've been using so far in this video and the previous one. And that would be to say, well, what's the relationship here? My w roots here are just 4 over my x roots, which means that x is 4 over w. So we just sub 4 over w into our original quadratic. 2 times 4 over w minus 4 over w plus 4 equals 0, and I can then multiply through by w squared. Oh, I forgot my squared here. Multiply through by w squared. We get 16 times 2 is 32, so 32 here. Here, when I multiply through by w squared, I get 4w. And here, when I multiply through by w squared, I get 4w squared. This can obviously be simplified down by dividing through by 4. And we get w squared minus w plus 8. And there's the answer. So personally, I think that's almost always the quickest way to solve these. There is an alternative method, and you will see that sometimes in mark schemes, along with the method I showed you. Very often you'll see a sort of method 1, method 2. Method 1, I'm about to show you, is often the one they put first. It's often very long, and then you see little method 2, which is the technique I've been using so far. Is so quick. So I do recommend method 2, which is this one. But have a look at the way which is often suggested. And that is to say, well, we want a quadratic with roots of 4 over alpha and 4 over beta. And it's to use sums and products of roots to say, okay, well, what is the sum of the roots? Well, the sum of the roots, well, we've actually done the hard work for this already, because that's just 4 times 1 over alpha plus 1 over beta, which we already worked out should be a quarter. So 4 times a quarter is 1. And what's the product of the roots? Well, 4 over alpha times 4 over beta is 16 over alpha beta. And we know alpha beta, it's 2, and that's 8. So what we now have is we know what the sum of the roots is, it's 1, and we know what the product is, it's 8. So obviously recall that the sum of the roots is minus b over a. And what about the product of the roots? That's c over a. And our job now is just to think of values for a, b, and c that make these true. And very often just setting a equals 1 is the easiest way to do it. So if you just say a equals 1, then minus b has to equal 1. So b equals minus 1. And c would have to equal 8. c over 1 should be 8, so c is 8. And there's my answer. It's 1x squared plus minus x, and minus x plus 8 equals 0. And look, that is the same polynomial as that. Now, why am I allowed to just state a value for a? Well, of course, there are infinitely many polynomials with these roots. It's just, if you took this quadratic and multiplied through by 2, that would be another solution, 2x squared minus 2x plus 16. So you can say I want a to equal 2 if you want. You can say I want a to equal 100. You'll just likely get answers where you could simplify it down. Setting a equals 1 is just the easiest way to do it. So those are the two approaches. One is to just use this transformation method. I really like that because it always works and it's always really quick. The alternative method is to find the sum of the roots, find the product of the roots. If it's a cubic, you need to find the sum of the doubles and the product, and then use that to kind of construct a polynomial by setting usually a equals 1. It works. You'll sometimes see it in mark schemes, but I've got to say I do prefer this transformation method. Okay, that concludes our work on roots of polynomials. I'll see you in the next video.